down to Red Bluff today to help with another Beringer install. We had a unique one. It'll be on a Savannah, which is real similar to a Zenith 701. It's got a really unique landing gear arrangement with the axle and the way the axle attaches to the spring gear. It's kind of an interesting setup, so we'll gotta check that out a little bit, see if we got all the right parts, make sure everything's compatible, and we'll put that together. I don't know if we'll get finished today, but we're gonna start anyways. Anyway, I'm warming up. I thought I'd take this opportunity to respond to Trent Palmer's last video about experimental engines. Obviously, everyone's entitled to their own opinion, and I think that he made some good points when it comes to low-time pilots building a plane that they're going to go out and build their experience in, and choosing a real high horsepower experimental engine. So you guys know this is a very experimental engine. I've got the Yamaha APEX in here. I also have the stock, not stock, it's got the aftermarket AEM fuel control ECU and everything on it. But the engine is stock. It's not, doesn't have any changes to the compression. It doesn't have a turbo added to it. It's as it would be running in a sled. So about 160 horsepower. So that is quite a bit more horsepower than a Rotax, but it's actually within the design capability of this engine. It's really designed somewhere between, you know, D-rated for the snowmobile at 150 to 160 to the motorcycle application of the same motor was at 200. So it's within the engineering of the engine. When you start getting into pushing horsepower past the design of the engine, like you know, the turboed version from certain companies, then you start pushing this engine past what it's designed to do. Then you start looking at, you know, the possibility of considering reliability versus power. I can tell you from flying this plane with 160 horsepower, there's, other than if you were going to race, there's no reason I have found yet where I needed more horsepower, other than going head to head with somebody that has more horsepower. The takeoff performance is incredible. The climb performance is incredible. It's so much more powerful than 100 horsepower. I mean, you're basically taking 50% more horsepower than the plane was designed to fly with. So a lot of the time I'm flying around at 48 to 50% power. And that's to get a nice convenient fuel burn. That's to fly around at about 100 miles per hour. So really, this engine has done everything that I want it to do. I'd like a little bit more horsepower for cruise without having to run at such a high RPM. But, you know, that's just part of gaining the horsepower for the weight by getting higher RPMs. That's how we were gaining that horsepower without adding weight. So, you know, in response to what Trent was saying, I kind of agree that putting a monster 300 horsepower engine in your first plane when you have low time it's just not really necessary. You know, if you think you're going to go right out and compete with the guys who are putting those monster engines in their plane specifically to win STOL drags or do really short takeoff and landings, you know, I just there's a lot of pilot skill and a lot of experience behind what those guys are doing. So I kind of agree with them there. Where I disagree is, you know, experimental aviation, the whole spirit of experimenting isn't to go buy a turnkey kit where it comes with like a Lego set and you put it all together exactly the way the book says and then go fly it. Why not just buy a certified plane? You know, if you don't want the options to do things your way, then that's what the certified market's really for. Experimental is experimental, and the only way to push aviation forward is to experiment on things. So, you know, I see the advantage of this engine. It's also not proven. So, you know, it may be a 500-hour engine, you know, before you have to do something to it. I don't know. We're waiting to see once we get the fleet hours on this engine. Is it going to have the same overhaul time as a Rotax? And I suspect not, because we're spinning it twice as much. You know, at 8,000 RPM versus 5 or 4,800 or whatever on a Rotax, the engine's spinning more, so you're going to probably wear it out sooner, would be my guess. We've had a couple guys look into their engines, one after about 400 hours, and the internals look great. So it really comes down to getting more time on the engines. There has been no case of an engine failure in flight that wasn't caused by the installer. In other words, the engines haven't failed just because the engines fail. We have engine failures in all kinds of aircraft, from Lycomings to Rotaxes to everything. And a lot of the time, it's not the fault of the engine. It's a bad install. It's a system that's associated with the engine that has a problem, fuel, oil. So I don't see this engine any more risky as far as engine failures. And his other point was, being a low time guy, you may not be prepared for an engine failure. Well, you shouldn't be flying if you're not, because any engine can fail at any time. So I don't necessarily think it's riskier to fly this engine than it would be to go out and fly a Rotax. I really don't. That's why I put my kids in this plane and go fly. That's just the way I feel about it. So that's where I disagree with him. Yeah, I do agree with some of his points. And again, everyone's entitled to their opinion when it comes to, and everybody has one when it comes to aircraft engines. So I think you should look at your options and see like my engine video, and go back and look at this engine video. I really go over each option and the advantages and disadvantages of each one. And to be honest, I would probably be running the same engine that Trent runs and his, the 915, if it wasn't so darn expensive. I think it's a good engine. I just couldn't bring myself to pay $60,000 to install it. So, but you know, that's my particular situation. Each person has their situation. So I'm gonna do a run up here, and then we'll get going. Anyway, so I'm cruising along. I've got about 5.4 gallons per hour, running about 59% power. Today with the temperature out, I've got a max power of 153 horsepower available. So I'm running about 60% of that. That's giving me a true airspeed of 100. Ground speed's 103, so a little tailwind. Temperatures have trued out at 167 on coolant, 180 degrees on the oil, which is perfect. I'm going to turn 100 hours on the Hobbs on this flight. I've had it about flying for just over a year, so about 100 hours a year is pretty average for what I do flying wise, because I fly for a living also. So you know, my free time, fun flying, about 100 hours a year. That's pretty common. Some years more, some less. I don't know if I use this or not, but I'm going to talk through the pattern here, what I do with this engine. So I pull the power back to usually about 5,000 RPM, bring the nose up. Below 80 miles per hour, bring in my first notch of flaps. A little up trim. On the Kitfox, when you add flaps, the nose drops on you, so I'm going to add a little bit of up trim. Slow up to about 65. I'm going to hold that 65 until I'm on final. I keep the speed up through the base turn. When I get to about 45 the numbers, I can start my base turn. Red Bluff, try the Kitfox turn in left base 33 full stop.
Red Bluff traffic, helicopter 6 Papa Golf with the run-up area to Compass Rose. We'll wait for you to land before we take off.
Alright, thank you, appreciate it. Base turn and base to final, nose down. Keep your nose down in your turn. Pulling that nose up, slipping or skidding as you come out of this turn is a stall spin inducer. So speed check in that turn and final at 65 still. I'm going to bring the power back. Go ahead and bring in a full notch of flaps. Bump the trim a little bit more for a little more aft trim. Just slow it up to about 55 now that I'm established on final. Get a nice stable approach. But aim for the touchdown markers. Turn a little power in. Now, power for altitude, pitch for airspeed. So if I'm too fast, I'm going to bring the nose up. Too slow, nose down. Crossing the threshold, I'm going to drop it down to about 50 miles per hour now. By bringing the nose up a little bit. Okay, come into the flare. Hold it off, we'll do a 3-point. Oh yeah. Firm. Firm 3-point. Flaps down. That's, if you can remember to do that right as you land, it really plants it. Now we got a taxi for half an hour. That flare a little high. Sometimes those runway illusions get me. When I'm out playing around in the dirt, you don't get the same thing. This is a much wider runway than my home airport, and it's an optical illusion that when the runway is bigger.
Red Bluff traffic, helicopter 6 Papa Golf with the present position departure to the west-southwest of
You
Red
may
Bluff.
flare a little bit differently because your perception of the width of the runway is different. Yeah, the Kitfox is clear. Thanks for waiting. I appreciate it.
No problem.
So once I clear the runway, I always like to clean up the airplane. And what I mean by that is put the trim back to takeoff position and flaps out. Turn off anything that doesn't need to be on. Lights, ADSB, leave my strobe on. I don't know if you can see out of this camera, but there's a Black Hawk taking off right next to me. Painted white blue, it is the PG&E Black Hawk. I don't know if that was helpful to talk you guys through an approach. Probably do the same thing for the takeoff at some point. Alright, I think it's this hangar.
Alright, so we're down here at Red Bluff and we're working on putting Beringer brakes on this Savannah. It's got a really unique axle. I'm going to take you in to show you that. We got the fan running because it's hot. So you won't be able to hear much of what I'm saying, but I'll show you real quick what's going on with this axle. So you can see it's got a through hole and then just one additional axle to point up there. So this is the axle that came off of there. Whoops. Kind of sandwiches between the two, and then the axle goes through this hole with a nut on the back. So this plate system has a keyway that prevents it from rotating. And that's really the whole system there. So Beringer has an adapter setup. Pops in there, locks it in position with that top one, and then we have a nut that goes on the back to sandwich the axle in. It's a really slick setup. It's got a spacer in there to move the tire out away from the landing gear. And we've got the other side done, so I'll take you over there, show you what it looks like when it's all finished. And Wanda decided to go with the 8-inch wheel with a Desser 27.5. You can see how awesome this is going to look. She did a custom fork on it. What size is your front tire?
20.5, I think.
Yeah, so nice big front tire with the 27.5.
It's the Aero Classic.
And then you can see how the
21. Yeah, 21 by
system went together. So everything's installed at the axle. We're just trying to work out the brake line system set up right now. We'll get the other axle on the other side done and then get going on the brake lines. Alright, so we're finished up with the Savannah install. Wheels on there. And the brake line's coming down. The only thing we're still waiting on is we need a fitting to connect the master cylinder to the brake line. And then once we get that right fitting, that'll be all taken care of. Bleed the brake system and it'll be good to go. But man, it looks substantial with these big 27.5 tires on it. I get back and do a profile. She made this custom fork and a big front tire. It's the Wile E. Coyote, huh?
Yeah.
Yeah, so it came out really nice. We're probably into it 5 hours on it, and So one of us figuring out these axles, but yeah, we got it squared away.
All right, so yeah, we just finished up with Wanda's Savannah. We did 8-inch wheels on there with the Duster 27.5-inch tires. We've done a fork modification and a 21-inch tire on the nose based off a 6-inch rim. I think it looks great. I think she'll be real happy with that setup. We had one more fitting that we needed to order to connect the brake lines to her existing master cylinders. Not something we really like to do using the existing ones, but in already flying airplanes, sometimes that's an option that the owners want to go with just out of ease of installation. In this case, I think it would have been actually easier to just go ahead with the Beringer masters, because she's going to have to take those masters out anyways to figure out the fitting on it. So, but that was fun. I always like to get hands-on new installs for Beringer. That way, when customers call and ask for help on their installation, I have a better understanding of how to help them through those installs, having done it myself. So the Savannah has a really unique axle. Now I know how it works, and it was actually pretty straightforward once we saw all the parts. I was able to get a schematic and exploded view of the engineering drawing on that installation, but we'd already got one axle on by the time I got a hold of that. So we just verified that we'd done it right, and it should be a really awesome setup for that airplane. Maybe my house meter only goes to 99.9. It's been there a long time. Should only be there for 6 minutes. There it is, 100 hours in the new Kitfox. Just over a year to do that. I haven't been flying very much the last couple months, or I would have hit that earlier, but 100 hours flying behind the Yamaha. Very happy with it. So it's great. Very stoked with the setup. But yeah, it's been an awesome experience with this airplane. You know, obviously the first engine with the head gasket issue was a bit of a bummer, but since I swapped that out, it's just been great. I mean, it's just run really, really well, and couldn't be happier with it. Now, there's critics of the Yamaha setup, but until we get the fleet hours on it, it is an unknown, and I understand the skepticism when you compare it to something that has the fleet hours of like a Rotax or something. The Rotax, you know what you're getting. You know what the known issues are and the troubles you have with that motor, with the carburetors, exhaust cracking all the time. I mean, those are issues you know you're going to have to deal with, and it's understandable. You also know what it costs. You know what the maintenance intervals are. It's a known entity, and it's a decent option. This one, it's kind of there's no track record, so it's truly experimental, and I like that aspect of it. I feel that any engine, if you watch what it's doing, make sure you're checking the stuff like oil analysis, oil filters, compression, take a look at the spark plugs. You know, the engine will talk to you. It will start consuming oil. It will start a reduction of power. It will start losing compression as it wears. And so I don't really see it as a scary thing to go to a conversion engine like this. There's going to be signs. I don't think you're going to have just straight up engine failures like you are going to be more common in this type of engine than it would be with a Rotax or anything else. I don't think that's the case at all. If the engine's wearing out, it's going to tell you. I don't think you're going to have catastrophic failure. You might have systems failures due to the install. You might have a problem with your oil line, your fuel system, fuel filters. That's true with any engine and any
Willow traffic stop.
Installation that's been done by an amateur builder, which I am. And so those variables are constant across all engine platforms. So to say that this is not a good option for your build, I disagree. I think this is a good option. It's affordable. It's got tremendous performance, and you can really put 3-4 of these engines in this plane before you would reach the cost of some of the alternatives. That's just the engine. You couldn't put 3 or 4 gearboxes in it. So, watching the gearbox, the performance of the gearbox, it's been really really solid. So overall, I think this is a great option. I'm real happy with it.